Hello, everyone. Today, we'll delve into one of the most profound and awe-inspiring topics in all of science and philosophy, the creation of the universe. This is a story that stretches across billions of years, involving events and processes that are almost beyond human comprehension. Yet, through the face-a lens of science, we have managed to piece together an extraordinary narrative that tells us where we come from and perhaps gives us a glimpse of our place in the cosmos. Let's begin at the very beginning, or as close to it as we can get. Our journey starts with the Big Bang, the event that marked the birth of our universe. The Big Bang is not just a theory, but the prevailing scientific explanation for how the universe began. According to this theory, around 13.8 billion years ago, the universe was an unimaginably small, hot, and dense point, often referred to as a singularity. This point contained all the matter and energy that would eventually form everything we see around us today. Then, in a moment of extraordinary expansion, this singularity began to stretch and grow. This event, the Big Bang, set in motion the expansion of the universe, a process that continues to this day. It's important to note that the Big Bang wasn't an explosion in space, but rather an expansion of space itself. Space, time, and matter all emerged simultaneously from this event. In the first fractions of a second after the Big Bang, the universe was in a state of extreme heat and density. During this brief period, the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces began to separate from one another. These forces would later govern the behavior of matter and energy in the universe. As the universe continued to expand and cool, it entered a phase known as cosmic inflation. During inflation, you feels me. The universe expanded exponentially, growing much faster than the speed of light. This rapid expansion smoothed out any irregularities in the early universe, leading to the relatively uniform structure we observe today. After inflation, the universe continued to expand, but at a slower rate. As it cooled further, the energy of the universe began to convert into particles. The first particles to form were quarks and leptons, the building blocks of protons, neutrons, and electrons. These particles would eventually combine to form the first atoms. About 3 minutes after the Big Bang, the universe had cooled enough for protons and neutrons to combine and form the nuclei of simple elements, primarily hydrogen and helium. This process is known as nucleosynthesis. The universe was still too hot for electrons to join these nuclei to form stable atoms, so it remained a hot, dense plasma of charged particles for several 100,000 years. As the universe continued to cool, it eventually reached a point where electrons could combine with nuclei to form neutral atoms. This process, called recombination, occurred about 380,000 years after the Big Bang. With the formation of neutral atoms, the universe became transparent to light, allowing photons to travel freely through space. This release of light is what we observe today as the cosmic microwave background radiation, a faint glow that permeates the universe and serves as a snapshot of the universe at that early time. For millions of years after recombination, the universe was a dark and featureless expanse filled with clouds of hydrogen and helium gas. This period is often referred to as the Dark Ages of the universe. However, gravity was hard at work, pulling together these clouds of gas into denser regions. Over time, these dense regions became the seeds of galaxies, stars, and eventually planets. The first stars began to form around 200 million years after the Big Bang. These stars were massive, burning brightly and living short lives compared to the stars we see today. When these early stars exhausted their nuclear fuel, they exploded as supernovae, scattering heavy elements like carbon, oxygen, and iron into space. These elements would later become the building blocks of planets and life. The formation of galaxies followed the formation of stars. Galaxies are vast collections of stars, gas, dust, and dark matter bound together by gravity. Our own galaxy, the Milky Way, began to take shape around 1 billion years after the Big Bang. Over time, galaxies formed clusters and superclusters, creating the large-scale structure of the universe that we observe today. As the universe evolved, so too did the structures within it. Our solar system, including the Earth, formed about 4.6 billion years ago from a cloud of gas and dust left over from previous generations of stars. This cloud, known as the solar nebula, collapsed under its own gravity, forming the Sun at its center and a disk of material around it. Over time, particles within this disk collided and stuck together, eventually forming the planets, moons, asteroids, and comets that make up our solar system. The Earth itself underwent a violent formation process, characterized by collisions with other planetary bodies, volcanic activity, and the eventual formation of oceans and an atmosphere. Life on Earth is thought to have originated around 3.8 billion years ago, starting with simple single-celled organisms. Over billions of years, life evolved and diversified, leading to the complex ecosystems and species we see today, including humans. Now, let's take a moment to consider the role of dark matter and dark energy in the evolution of the universe. While we can observe stars, galaxies, and other forms of matter, they make up only a small fraction of the total mass and energy in the universe. Most of the universe, about 85% of its mass, is made up of dark matter, an invisible substance that doesn't emit, absorb, or reflect light. Though we cannot see dark matter directly, we can infer its presence from its gravitational effects on visible matter. Dark energy, on the other hand, is a mysterious force that is driving the accelerated expansion of the universe. Discovered in the late 20th century, dark energy makes up about 70% of the universe's total energy content. Its exact nature remains one of the greatest mysteries in modern cosmology, but it plays a crucial role in shaping the future of the universe. As we look to the future, scientists continue to study the cosmos, seeking to understand the ultimate fate of the universe. Will it continue to expand forever, eventually leading to a cold, dark, and lifeless state known as the heat death? Or will gravity eventually slow down the expansion, leading to a big crunch where the universe collapses back in on itself? There's even the possibility of a big rip, where dark energy could tear the fabric of the universe apart. These are questions that remain unanswered, but they inspire us to keep exploring and learning. The creation of the universe is not just a story of distant events. It's a story that continues to unfold with every passing moment. Each new discovery in astronomy and cosmology brings us closer to understanding the origins of the universe and our place within it. In reflecting on the creation of the universe, we are reminded of the vastness of the cosmos and the smallness of our own existence. Yet, we are also reminded of the incredible power of human curiosity and the drive to seek out answers to the most profound questions. The story of the universe is our story, a story of beginnings, of exploration, and of the eternal quest to understand the world around us. Thank you for joining me on this journey through the creation of the universe. I hope it has sparked your imagination and deepened your appreciation for the mysteries of the cosmos. Thanks for watching. Subscribe to the channel, like, comment, and share.